Hello and welcome to a webinar hosted by Oilfield Technology with Tracerco. I'm Elizabeth Corner and thank you everyone for joining us. Today's session covers Tracerco's latest evolution in upstream technology to benefit your E&P opportunities. We're going to explore the challenges of field development from exploration to multi-well developments and all the way through to enhanced oil recovery. We'll talk about the applications of chemical tracers in conventional and unconventional wells. And in doing so, we'll talk about some solutions to solve the most difficult oil and gas production problems related to geology, reservoir, production, and completions. We'll begin proceedings today with a presentation and then follow this up with a Q&A session with questions from the audience. Your presenters today are on screen. They are Patrick Hayes, Business Development Manager, Clint Shaw, Technical Sales Consultant, and Mariano Clarisi, Technology Manager. If you would like to submit a question at any point during the presentation or during the Q&A, here's how you do it. If you are joining the webinar on a mobile or cell phone, you can access the question box by tapping the Q&A icon at the bottom of your screen. If you are using a desktop or a laptop, you can click the Q&A icon on the top right of your screen, click Ask a Question, and then type your question into that box. Everyone who registered to attend today will receive a recording of the full presentation via email, so you will be able to recap and watch again. Okay, now before the presentation begins today, we'd like to begin with some audience participation, partly to check you're all wide awake and ready to engage, mostly to gauge a bit about the demographic of our wonderful audience today. I'm going to be running two polls and you should see them on your screen now. The first poll is, have you ever used chemical tracer technology and where, with the options of offshore and onshore? So the answers are yes onshore, yes offshore, yes to both, and no. We'll just wait a second while everybody contributes. Okay, 50% yes offshore, with about a quarter saying no. Okay, great. I'm sure that will continue to move. Let's ask the second question now. Poll question number 2. Is there a particular technology you would like more specific information about? So completions tracing, inflow tracing, or interwell tracing applications. If you wouldn't mind giving your answer now. Here we go. Okay. That is weighted towards the interwell tracing and the inflow tracing. Brilliant. Thank you so much for your participation. It's now time for me to hand over to Patrick, Clint, and Mariano for their presentation.
You bet. Thank you for that introduction, Elizabeth. Really appreciate it. Looking forward to sharing some information with everybody on Tracerco's latest evolution of upstream technology benefits that will help your E&P opportunities. So we'll start with just a little bit of an overview of what Tracerco's mission is. You know, our mission is to provide access and insight and analysis to solve some of the world's hardest challenges when it comes to measurements and data acquisition. That's really Tracerco's foundation from the very beginning, and it's still our foundation today. A little bit of history here about the company itself. Established in 1958, holding more than 350 patents around the world, with thousands of different types of customers from the subsurface all the way through distillation and downstream activities. Over 65 years of insights through innovation, really focusing on those challenges I mentioned before in our mission. And you know, in order to accomplish these things, we've had to make a huge investment in the research and development side to stay ahead with innovation and continue as technology develops and the means of measurements become more important and more difficult. So with this, Over the last 65 years, we've created multiple disciplines within the business, creating business units focused on particular problems, either on the diagnostics services, looking at online processes in midstream refining, all the way through to production, as well as in the subsea environment, where we look at hydrate detection, flow assurance issues, even to the extent of integrity and investigation with specialist measurements, all the way down to a subsea CAT scanner that works at 10,000 feet. Unbelievable. We have our nucleonics research division and instruments division that's focused on specialty measurements within processes to provide exact measurements of densities, phase changes, so the optimization can happen on the midstream side as well as processing in downstream. Of course, I'm focused on the reservoir side, so I'm a little bit partial to this particular side of the business, where we're focused on subsurface characterization using chemical tracers. We also have radiation monitors that work with militaries, fire departments, increasing health and safety for those folks in the industry that are contributing to our energy supply and our safety. And then carbon authentication. Carbon authentication is focused on areas of product adulteration, tax evasion, right? And then also the environment, making sure that all of the different emissions methods are held to. So lots of different applications here. Within Tracerco, today's focus, of course, will be on reservoir. Tracerco is a leading provider in value, and what does that really mean? All of the measurements that we're have developed over the years are really focused on a return on investment and meeting those challenges that are needed to progress the industry. In the subsurface environment, we're talking about the use of chemical tracers. Now, when we look at chemical properties and chemical characteristics, they have to be quite specific to provide value and be effective in measuring the conditions and phases that are desired. Folks have asked me over the last 2 decades, what's changed within Tracerco, right? And in reservoir tracing capabilities. Well, we've gone from a rotary dial on a desk all the way through to being able to watch a full HD movie on our cell phone. Limits of quantification and the technology of detection have really advanced over the last 2 decades, moving from parts per million to parts per billion to parts per trillion, and now even into the quadrillionth, which is just a phenomenal achievement for a forensic science type application for phase specific measurements. These chemical tracers, of course, have to be stable and inert in the environment. If we could use chocolate milk to make the phase specific measurements and provide the value, we would. However, we wouldn't provide the correct answers. They need to be easily detectable, not naturally present, not a comparison to something that's naturally within the reservoir, but something that was physically placed there. So we're actually measuring actual communication pathways and actual production rather than making an association with the subsurface environment. They need to not be influenced by the chemistry that's being injected into the reservoir, right, during the process of hydraulic fracturing or EOR applications. They need to be non-toxic, right? We're talking about chemical tracers, not the use of radioisotopes that may create some hazards for the handlers as well as specific disposal routes. When I spoke about those achievements in detection, how does that influence the operator's decisions to use chemical tracers? Well, projects that previously needed multiple hundreds of kilos now may only require 1 or 2 kilos of tracer, and it greatly impacts the economics and that return on investment. And of course, the tracers need to follow the phase it's intended and provide the measurements that's required to meet goals and objectives. When we speak about tracer behavior, right, we're talking about if the desire is to follow the liquid oil produced phase out of the formation, the tracers need to only be produced under those conditions, not in the gas phase or with the produced water, for example. Those tracers need to behave the same. The characteristics are really, really important in what the data is going to provide. If a tracer doesn't produce the same and is influenced by something within the reservoir, calibrations are not an adequate way to deal with that because the subsurface environment changes and its contact with those items that may retard its production, for example. So Tracerco holds extremely stringent criteria on its tracers so that they produce in a way where the reservoir is not going to influence the outcome of the results, but more the physical flow and physical phase production is related to the recovery of production of tracer. Now, solids, we've had massive developments over the last few years when it comes to solids, solid release rates, and an understanding of those impacts. Solid tracers under steady state conditions in most cases are not quantifiable, but a binary answer, a yes, no. And we can jump into that just slightly in the next slide. Gas phase tracer production. As gas tracers are more used widely in EOR applications, it's a need for an understanding of that particular tracer's movement in the formation in comparison to the composition of the injected gas being utilized for that enhanced oil recovery. Mariano, in the later parts of this presentation, is going to focus on some unique methods of partitioning tracers, right? And we spoke of that mass amount of research and development, PVT cell testing, thermal degradation testing, and also understanding the K factors of our tracers so that we understand fully what are we really measuring. There's some facts and fiction. I've used this slide before, but I think it's really, really important to understand that the physical forms of tracer applications are going to greatly impact the quality of the data and its ability to solve the objectives, right? Meeting those goals is, of course, the most important thing that we can do. Particulate tracers are a qualitative answer under steady state conditions. And even the construct of that particulate is going to affect how it releases over time. Absorbed particulate materials are 100% reliant on the properties of that chemical's characteristics and its contact with that phase. In some cases, releasing before it ever even makes it to the formation during stimulation. The second type that's out there is actually a manufactured particulate. And the manufactured particulate is designed to control that release rate to the desired objectives, timelines, and goals of the operator. When we talk about encapsulated tracers and particulate tracers, Tracerco has a unique method of microencapsulation to extend lifespans, right? And then when tracers are applied to a specific area and location, through transient analysis and peak arrivals, those can be quantified to the specific phase of production over a long period of time. Now, liquid tracers and gas phase tracers are the only quantitative solution under steady state condition. This is 40 years of proven technology evaluating communication between injectors and producers, now applied to unconventional wells and stimulations in the appropriate application method can quantify production of water, oil, and gas per stage and assist operators not just in early production, but production management, and then, of course, in exploration as well. Clint Shaw is going to go into great detail with that and throw some examples out there on how that can assist in the efficiencies of production. Partitioning tracers, I'm not going to steal Mariano's thunder here, but partitioning tracers involve the use of a tracer with a known partitioning coefficient to the oil phase and a passive tracer. And that comparison can be utilized to quantify remaining oil, not just from an injector to a producer, but also when we look at single well test. I spoke a little bit about solids, absorbed solids versus encapsulated solids, and the liquid tracers that are utilized to quantify both production as well as communication in unconventional laterals. So I'm going to show you an example of one comparison where we'll be looking at an absorbed solid material versus encapsulated. Once again, an absorbed solid is a porous material that's soaked in tracer and then applied, versus an encapsulated tracer, which is truly manufactured and designed for reservoir temperatures and flow rates to meet customers' goals and objectives and provide a more linear release rate that also provides longevity over time. So when we look at this following slide, we'll be looking at a comparison between the two, with the top utilizing a manufactured material with encapsulation in comparison to an absorbed bead material. Now, the first set to the left, so starting with the first block to the left, the top graph, line graph, provides the production from the wellbore that the tracers were applied to. And that's the polymer tracers on the top. All subsequent blocks moving to the right are offset wells that were sampled. And we do see some communication with those offset wells. However, over time, it diminishes to next to nothing and represents more of a communication of the prop and frac. The absorbed beads on the bottom, again starting to the left, are from the injected well, followed by communication with all offsets. Now, the absorbed bead material indicated larger amounts of communication, showing significant initial losses, potential crush, production of fines, and non-related spikes in production to the actual amounts being produced. So if the investigation and the goals and objectives are to understand long-term production from the prop frac length, a polymer tracer is an ideal candidate, especially if you're looking at long-term tow contribution of a well. If workovers or sand production are an issue where bridging exists, those are a good application method for this. Okay, with that, I'm going to conclude my initial part of the presentation and hand it over to Clint Shaw for introducing some of the unconventional applications and some of the updated changes. So with that, I'm going to hand it over to you, Clint.
All right, thank you, Patrick. So the theme of the presentation is what's new with Tracer and Tracer technology, right? So Tracerco is constantly innovating to meet the market, and we've got a tremendous amount of history, as Patrick explained, doing tracing all various different kinds of projects, and we are always looking at ways to bring that to the new changes and challenges in the market and in the industry. So initially, tracers were used working left to right here on this slide. like conventional EOR type projects where we would do a pulse injection. You inject the tracers, they move through the reservoir. We would collect samples at producers, and you've got to catch that breakthrough and see what the shape of that curve is to characterize the reservoir and the flow pathways through the reservoir. And that would be kind of like the first initial iterations of tracer technology. And then as things developed more into horizontal drilling and fracking, we started applying tracers in continuous injection across the entire frac stage. So as Patrick alluded to, if you want to quantify where tracers have gone and what production looks like over time and communication between wellbores or between benches within a reservoir, you need to trace that with a liquid tracer at a fixed concentration over that whole fluid, over all the fluid that's applied. That's the only way you can quantify that in the returns, is looking at the mass that's recovered after applying it in that manner. And then now a lot of what we're seeing, I mean, we're still doing a lot of both of those applications, whether it's water flood, CO2 flood, frac, horizontal frac, vertical work. We're now also seeing a lot of unconventional EOR. So it's kind of a merger of this history that we have, where we're now doing long-term continuous injection in EOR type applications in unconventional reservoirs. I'm gonna again work through this slide left to right. I've got 3 different examples here. So what matters to us, we can make pretty pictures all day long. The pictures are just, you know, they're beautiful, but what do you do with it, right? We care about what the customer is able to do with the data that they gather from tracer projects with Tracerco. And on the left-hand side here, this is an example. The top image is like a before, and the lower image is an after look at what happened in this wellbore. So this operator ran dissolvable plugs, and they wanted to know, did our plugs dissolve? And we were able to look at this data and prove that there had not been any flow from below about 2/3 of the way down the lateral. And they went in, drilled their dissolvable plugs, and they were able to get returns from that lower portion of the horizontal. The middle example here, this is looking at reservoir quality. This is a still shot of a video I'm about to show you in the next slide. And it's an example of what we can do with like a 4-dimensional multivariate analysis, where we can look at geology data, reservoir, completions data, drilling data, and lay production over time over all of those factors. So we can give you a really solid tool to evaluate many different things that are happening, because we all know, as much as we would all like to fix every variable except for one, so we can learn something from the scientific method, that's not the way that the rocks and the geology works, right? And completions and everything that goes into that. So we're able to look at reservoir quality. And then on the right-hand side of this slide, this is an example where the operator, this well was kind of a dog. It made a lot of water and did not make hardly any hydrocarbon. It was making a little bit of oil. And we saw where there was a lot of water coming from the lower 2/3 of this well. The operator moved in there and set a plug. And then we saw that this well improved dramatically in oil production. And you can see that there's still some water production there in the hill of the well, but the oil production spiked. You can see it there on the green bars, and that's going to represent the oil that returned in the tracer, and the blue bars is the water returns. So I'm going to show you that video of that middle slide, and you can see what's happening in this one. Time is an important component, because what you see on day one, the daily bars are the ones that are kind of changing up and down that you see. That's going to be daily production. The bar that you see growing continuously, that's a cumulative look, the darker green. So what you see on day one versus what you see on day 60 or 120 can be very different. And so it's important to look at what changes over time. The red trace on here is on the bottom. That's the mud log. The gas shows in the mud log, and we can look at what the reservoir looked like as they were drilling that. Let me go ahead and click over to the next slide here. Okay, another thing that's changed a lot, as we know in the horizontal unconventional development in the U.S., is these multiple benches that are being completed, and looking at things like order of operations, which frac stages are completed first, stress shadowing, building a pressure wave to try to contain fractures within certain reservoirs, or looking at depletion. And we're able to look at all of that with tracer data. So you're seeing kind of a gun barrel view of a reservoir here that has multiple different wells landed in multiple different targets. And over on the right-hand side, that image there that shows the well traces with some bubbles on it. I'm going to show you this video in just a moment, but you can see where we grouped stages together. So each color represents a group of trace stages. That's oil production. So we had like 5 stages grouped together for this study. And I'm going to show you, let's go ahead and look at that video. So in this video, the upper green well was the traced well. We may play this video twice because I want to explain something here. The upper green well is the traced well. And this is gonna be cumulative oil tracer that you're looking at. Marilee, if you don't mind, play that again. What happened here is they brought the lower wells on first. So you see that oil tracer show up there. Then they started bringing on the wells in the upper bench. And you can see that communication doesn't necessarily persist over time. It was a function of how the wells were brought online. You mainly just see communication to the well next door to it. Okay, I'll go ahead and skip over to the next one here. Okay, and so I alluded to this evolution of what's happened with tracer and how we're now using continuous injection for EOR applications long term. I'm talking weeks, months in some cases with high volumes. So Patrick is going to pick back up and talk some more about that.
Clint, thank you for that. I'm going to speak a little bit about EOR applications. It's really going to apply to unconventional EORs that are being done in today's unconventional fields. We're going back, we're looking at wells. There's being refracs being done. There's being zones that are being included that previously weren't part of the initial completion. There's a lot of remediation being done. Pumping sand with every kind of jello out there has been decided not to be a good idea. Skin damage does exist. Formational damage does exist. And there's opportunities to do remediation in that segment. With the CO2 being an active topic around the world, and emissions being an active topic around the world, there's more projects involving huff and puff, where we're talking about the injection of gases and different gas compositions to recovery. I know this is a little bit of a comical slide, guys, very unserious. However, this is what we're talking about doing. We're talking about using our energy and different methodologies to inject into a well, make some changes, and produce back from a series of different wells. So what we're facing now in comparison to an unconventional completion is that there's multiple wells being injected into over periods of times at different pressures and different rates to create an environment that produces more oil out of parent wells or fully developed fields, areas where secondary recovery in an unconventional may have some economic viability. So that has created a situation where we really needed to scratch our heads and look at this and say, what's going to deliver the most information, the highest quality information and represent what's happening in the subsurface. So I'm going to walk you through just one particular project, some pieces of that project and the information that it provided. This graph represents actually the injection concentration of tracer per volume in 3 different wells. The green, the blue, and the yellow are different wells injecting simultaneously into a particular formation. And what we're doing is applying a consistent rate of injection. And during that time frame, in some cases that can be multiple months, we take a few QCs to ensure that that injection is providing a constant concentration. Now, we're luckily nowadays we can actually do a lot of remote monitoring, match DCS rates, all those kinds of things. Some of the challenges that we couldn't accomplish just a decade ago. After the injection cycle, during a huff and puff or surfactant injection cycle, the wells are put back on production. So now we're looking at the tracers that were applied to one of those 3 injection wells and being produced from that well. With the concentration produced and also the known volumes being produced, we can actually work out the masses of recovery and percentages of recovery from the injection gas. So we start by looking at what was actually injected into that particular well and what those percentages of recovery look like. Then we take it a step further because communication is expected amongst all of these wells, and we want to understand, what does our breadbox really look like? What does this fracture matrix look like? And how much are we communicating with offset wellbores? So this particular slide, the pie chart starting at the top left, represents purely percentages of tracer recovered from the injected well and its communication with offsets, purely in a percentage basis. Now that can provide value, percentages of communication and percentages of recovery. However, the most valuable piece of information is really understanding the quantities. And through this methodology, we can actually represent the quantities, which is the bar charts in the top right. So we quantify what are the actual recoveries of my injected gas from the injection well, as well as its offsets, and how does that relate to percentages of recovery as well as economics. The bottom plot is simply a 4D image that in this particular instance represents the cumulative communication with the offsets in the different benches and in the same bench from the injected well, which is well 5 in the bottom right corner with the square around it. It's been really neat to adapt our tracing technology to the different needs of measurement to help efficiency grow amongst the industry. Now with that, Mariano's going to speak about a different type of application involving EOR as well as single well chemical tracer techniques. So with that, Mariano, I'm going to transition one more slide and hand it over to you, sir. I'm not. It appears that he's muted, or that his microphone's not working. So I'll pick up the presentation for Mariano here. I'll do my best to accommodate and work through these slides. So if we could go ahead and play the video for this particular slide. This is a description of partitioning tracers where 2 tracers are applied. One, the blue one, being a passive tracer, and the second one having a known partitioning coefficient. To put things quite simplistic, and this is of course oversimplified, but we know that the passive tracer does not interact with the rock properties and will move the fastest through the formation. The partitioning tracers are going to shake hands with that oil molecule, which is going to slow it down as it moves through the formation. The different arrival timings can be utilized to calculate remaining oil saturation, both in an interwell perspective from an injector to producer, but also from a single well test, from a tracer that is applied into a well and produced from a well. Having the correct partitioning coefficient is extremely important. If we pick a tracer that will move too slowly through the formation, it may take decades to show up, and that's not going to meet goals and objectives. So we have to have an understanding of what is that partitioning coefficient? What will that transient time be from an injector to a producer, or from that single well chemical tracer test? And in order to achieve this, we have to do calculations under reservoir conditions using PVT cells, right, at pressure and reservoir conditions. So we actually take dead oil, we look at those partitioning coefficients to develop the right tracer strategy for your particular project. And this has been proven to be extremely successful and a great methodology towards the approach. So for people simple like me, here's another graph with a few calculations on how we actually measure remaining oil saturation. This was a particular methodology that I thought a little bit difficult to understand, and having a few more slides might help. So the blue trace is the passive tracer arrival. The passive tracer arrival pulse. The red trace, the second trace that arrives later in time, is the partitioner. Again, utilizing those mean residence times and arrival curves, we're able to accomplish a remaining oil saturation by incorporating that K factor that was developed in the PVT lab. I'm going to go through a specific case study. It'll be quite quick. This particular case study happened in Oman. It had to do with the use of an ASP flood, making some changes to the chemistry of the injected fluids. And before implementing something like this to a full field where there could be significant cost increases with significant recoveries, the challenge came to say, what is the actual change seen from the injectors to producers? Now, this was actually a phenomenal case study in that not very often do you have the opportunity to drill 7 wells as a project. 7 pilot wells were drilled. A monitoring well was included in the 7, and a series of steps were evaluated. First, looking at the conformancy between the producers and the particular injector, the blue circle being the injector and the red circles the producers, yellows being existing offset wells. A passive tracer was applied to understand the conformance in the initial phase. The second was another conformance test after channels had been created. So we had a pilot study, initial injection, a time frame of conformance, an evaluation of change of that conformance and reservoir communication after a year of production, and finally the initial injection of partitioning tracers to calculate initial remaining oil saturation, followed by the ASP application and a secondary test of its conformance and what remaining oil saturation existed. So here are the first two phases of the study that show the quick change in swept pore volume and the efficiency of the flood. The top being the initial passive tracer injection, its mass that was injected, its percentages of recovery, the swept pore volumes, and Lorentz coefficients, moving from left to right. Followed by this was the injection of the passive tracer with two different partitioners. Now, two different partitioners were used to enhance the accuracy of the data. I won't go through every plot here, but we can start with the top left. The blue trace being the passive tracer, the green trace being one of the partitioners, and the red trace a secondary partitioner. Off to the right is where the sophisticated calculations and software usage that Mariano does works out the remaining oil saturation. And based on this particular case study, we were able to accomplish the pre and post measures that presented a change from 36% to a mere 2% within the swept pore volume. Now, single well chemical tracer test. Now, this is a real challenge because we have to create one of our tracers in the subsurface environment. If we use our traditional partitioning tracers, can you still hear me, Clint? All right.
Yes.
If we use our traditional partitioning tracers and we injected two tracers at the same time, the passive tracer would move fast and furious through the formation, leading that partitioner as it interacted with the oil. When the well was turned around and produced to the surface, the passive tracer again would move at a more rapid pace than the partitioner. They would come together, and we would have inconclusive results. So in this particular case, we have to make some changes. On the top right, you can see that we're injecting a tracer over a fixed volume. We push that into the formation, and then as it soaks, we have a process in which a second tracer is created. Now, Elizabeth is going to do us a great favor as I transition. I think a picture's worth 1,000 words. This video is going to show that process in which we were discussing. A displacement of mobile oil, the injection of a fixed volume of tracer, the creation of our partitioner, and the subsequent recoveries that determine that remaining oil saturation measurement. So in this particular case, again, we use some different types of proven software to calculate the remaining oil saturation. So I'm ready to move on to the next slide there, Elizabeth. So we've done extensive work in a global network applying these types of applications with more than 20 locations around the globe, specifically coordinated lab locations for quick turnaround and quick results to our customers so that we can meet those specific needs, from flow assurance that Clint specified to the more complex efficiencies gained through the evaluations of incorporating principal components and phase production. So as a conclusion, chemical tracers provide an understanding of phase movement and recovery that can significantly add value to existing measurement tools. The who, the why, the what provides the return on investment coupled with its production implications. It creates the link between the stage to stage production, the geology, stimulation design, and reservoir properties. Although many tracer technologies exist, only chemical tracers applied in the correct physical forms as a liquid with the appropriate phase-specific properties can be used to quantify production under steady state conditions. Advancements continue with chemical tracers not only to increase the numbers available, but find suitability within an evolving industry that is really working at an extremely fast pace to provide energy for the world. So with that, we'll go over to Q&A, Madeline. I'll try to answer some questions as well as Clint.
Thank you so much to our presenters. Excellent work. Mariano, we've been trying to get you back on screen. Here you are. Let's hope we can hear from you because you're an important part of this too. We are going to move to the question and answer section now. If you are watching and you haven't asked your question yet, now is the time. We do have lots coming in, but if you really feel that you've got something that hasn't been answered, then do pop that in the question box now. So looking at the questions here, there are a few of them focusing on geology. So let's start there. So Surendra is asking, can the mineralogy of the rock affect the performance of a selected tracer?
I'll grab that one. I think that's a fantastic question. We spend an enormous amount of time and investment, financial investment. Mariano's group works tirelessly to do an enormous amount of work to make sure that the tracers are not affected by the reservoir geology and the reservoir environment, and that they represent the actual production that's being intended to be measured. I think that's a big differentiator. There are some tracers out there that are specifically made to partition into specific geologies, similar to remaining oil saturation, but that's not something that Tracerco provides at this time. We are really focused on providing accurate measurements of specific phases of production and remaining oil saturation. So I hope that answers the question.
Another one here about single well tracer tests. So what is in general the radius of an investigation for a single well tracer test study?
Mariano, you want to capture that if your mic's working? No, can't hear you. We got troubles. That's okay. I can do this. It's going to be slightly different in specific formations on the amount of displacement that's achieved and the volumes available, and economics will drive part of that. But generally speaking, we're talking about a minimum of a 15-foot displacement across a pay zone that's being investigated. Mariano, I'll let you just nod your head if I answered that right.
Let's move on to our next question. Can tracers help in knowing the overall volumetric sweep efficiency for an EOR method?
Liz, I think that's a great question. You know, Tracerco was involved with looking at communication between injectors and producers when radioisotopes were really the only option to do that type of measurement. So we've got over 4 decades of doing that specific thing. Some of the enhancements, I believe, in the recent technology is those limits of detection help you characterize the smaller communication pathways and sweeps seen between injectors and producers. So being able to do that forensic type analysis and get down to those lower levels of detection really help you see more clearly what's happening in the subsurface and how it relates to the models, the fantastic models that are out there, and able to make those adjustments.
Here's an interesting question for you, which you may decline if you'd like to. Can you rank today's discussed tracers by cost? So cheapest to most expensive. Is that something we can talk about?
I think so. I think everybody on the call understands if I ask the question, how much does an oil well cost? They'd all throw up their hands and say, well, it can be from here to there. Generally speaking, the tracer costs are similar to the project design and objectives. So I wouldn't say that there's one tracer that's more expensive than the other. There's potentially a goal and objective that makes for different volumes, masses of tracers required that's going to impact the cost. Some objectives may require large amounts of tracer, and of course, that's going to increase costs. Some projects are going to have tiny amounts of tracer required, and of course, that has a significant impact on cost. The other thing that definitely needs to be incorporated into the cost of a project and its design is what operator operations are going to be required to support the activity. So most of the time, that part of the project outweighs the tracer cost when we start talking about offshore projects, the use of inflow tracers and adding things to lower completions. So tracer projects are generally a small portion of the overall cost of a project. And there's a lot of things that can impact it outside the tracers themselves.
Our next question comes from John, who asks, how is a tracer spotted for open hole horizontal completions?
Oh, wow. I might even know who this John is. Oh, my goodness. Well, there's definitely some different operational capabilities that can be done either through the bit, by injection of a tracer material as a solid at a given location. But that would require some sort of intervention or tool utilization. And then of course, there's completion tools that can be left behind. It's going to be about, do I want to have a yes, no? Do I want to have a volumetric measurement from the sections of the lateral? What are my operational capabilities and access into the locations where we're wanting to measure? And what's that associated cost beyond the tracer materials themselves? We, as Tracerco, try to optimize the opportunities to apply tracers where there's no change in operational functionality or cost. But in some cases, it's almost unavoidable where in order to capture the measurements needed, there's going to be some added operational things that need to happen. EORs are done under steady state conditions under most cases. So you're not looking at a lot of different things that have to be done. However, if you have an existing well and there's activities that need to take place, we can usually couple those tracers to that specific activity to meet goals and objectives. So I know the cost thing's kind of a crazy one, and this is another one where there's a lot of different options, and it's going to be based on ultimate goals.
Questions are flying in, so we'll move on. This one says, can tracers be useful for monitoring purposes in CCS projects?
Well, I'd love to softball some of these over to you, Mariano. CCUS. So CCUS is a huge undertaking. There's a lot involved in construction, permitting, MRV applications, approvals. There's so many opportunities as well to benefit the environment. Adding tracers to CCUS projects provides leak detection, verification of zonal isolation, migration paths, frontal wave distinguishing when multiple injectors are involved, interpretation of the causes of potential issues or migration versus models. There's just so many different levels of security that are provided when integrating tracers into CCUS projects. And the low cost just makes it it's almost a no-brainer. Really. So, yeah, there's a lot of opportunities there. We have a group, Heinz and Frederick run that, are over that specialized service. Happy to pass on contact details if somebody wants more information.
Great. Let's skip on to our next question. This is Luciano asking, are you aware if your customers have had success in certifying reserves using SOR results from Tracer experience?
Certifying reserves. We've been able to accurately measure it, and it has been compared. As I mentioned in the previous case study, there was an observation well where they ran different kinds of logs to calculate remaining oil saturation, and we had a very good pairing with that. I don't know of a certified entity that would provide that kind of certified certificate, if you will, to the methodology. Maybe Mariano can follow up with that at a later time. I'm not sure.
Great, absolutely, we can follow up directly. Here's a question about interwell. You mentioned that interwell traces are quantitative, but to what level of accuracy is the question? So how could you maximize the accuracy of the data?
Absolutely, we can maximize the accuracy of the data. When we speak about accuracy of data, there's a couple of components that come together with that. One of them is understanding the production of the specific phase. Second is ensuring that you have a sampling methodology that captures the specific points that are required to make those measurements. What I mean is that we need to be able to capture the leading edge, the peak. We need to be able to determine the mean residence time. So as long as your sampling program and your measurement methods are pointed to the goals and objectives, you can get extremely accurate measurements of sweep efficiency, and you can produce Lorentz coefficients measurements. There's hundreds of SPE papers out there on the quantification of these pathways utilizing chemical tracers. So
we'll move on to our next question because there are a lot to get through. This one says, can tracers help in conducting root cause analysis of a mid-course problem during EOR application?
A mid-course problem. I'm not exactly understanding that particular terminology or framework. Clint, do you understand what's meant by a mid-course problem? I think this one requires some more investigation.
Yeah, I'm not sure.
We will move on then, that is fine. So I can see a question here about SWCTT. What are the risks involved when doing this kind of tracer testing, and how might you mitigate the risks?
Oh, wow. Now you're getting down into some very specific operational activities. What I can say is that the tracer study itself has very limited risk. Of course, as you saw on the slide, when you look at single well chemical tracer tests, there's going to be some operations that have to take place, which means that your wellbore has to be in reasonable shape. The wellbore needs to be representative of the goals and objectives and the status of the field. There's going to be operational conditions that have to take place, which means that there's an injection phase. So there needs to be injectivity into the well. There's going to be a producing phase, which means that you have to have disposal of produced fluids, be that additional hydrocarbons produced that hopefully can be sold, but those have to be dealt with. If you're adding CO2, there's transportation of CO2 and injection of CO2 during that process. So from a tracer perspective, the operational risks and any effects that the tracers could have on the formation is as close to zero as you can get. However, the operations that needs to take place, the displacement of water or displacement of mobile oil, the injection of water, and the recovery, be it by rod pump or under natural flow. Many cases, there's not natural flow under the conditions. Those are really where the operational risks fall with that particular application.
I want to squeeze one more question in,
Okay.
if that's okay with you. This one is about the inflow tracers. So you mentioned that they are a long-term production tool. This question asker has said long-term is relative. So what would you estimate as the life expectancy of the tracers?
Wow. How much does the well cost question again? When we talk about longevity of tracers and encapsulated tracers and their nature to be phase specific, they're not going to deplete unless contacted with the phase. There's a lot of conditions that are going to impact longevity. One, how much can I actually apply? Luckily in unconventionals, right, there's a large area in which the tracers can be injected into. When it comes to inflow in a conventional well, I'm going to be restricted to the actual mechanical design and completions below and what allowable space there is. So in most cases, dilution is really the tracer's enemy. Eventually, it becomes depleted beyond those points of limits of quantification. So you're 100% right by asking the question and making the statement of it's relative. In some cases, we get decades. In other cases, we get years. It's really going to be dependent on what we have. Mariano's team, the operational team from Justin Tippett have worked tirelessly to create tracers and manufacture them for the specific reservoir conditions. They've incorporated microencapsulation, a patented method that Tracerco has come up with to further protect the tracer from the phase so that we get increased lifespan. So it's definitely relative. It can be years, it can be a year, or it can be a decade, depending on what the flow regime is at the time.
Okay, thank you so much. I think we will wrap it up there because we've gone over our hour. I'd like to thank our presenters for their input and for answering questions. If we didn't get to your question today, rest assured it will be passed to the team at Tracerco and they will respond to you directly. You can look out for the full recording of the session that will be delivered to your inbox in due course. And if you would like to read a regular copy of Oilfield Technology, you can click on the button that is appearing on your screen now, or should be. There we go. And you can register for free with a click of a few buttons. So thank you so much, Patrick, Mariano, Clint, and thank you everyone for joining us today. Bye-bye.